Welcome students. We come to the second portion of mathematical tools of concept of calculus. Now I hope you remember that we had understood the differentiation process and now we are going to have the mathematical part of it. Now the value of this differential when we put it as x to the power n is simply given by n x to the power n minus 1. So all you have to do is to remind this formula and go on applying it. Say for example, I am asked to differentiate x square. So in that case what I do, I bring the power in front of x and then I multiply from the power a value of 1. So that will give you 2x. Now say if I have 3x square, then what I need to do is keep 3 as it is and then multiply the operation of x square, which is 2x. So that gives me 6x. So this is fundamentally the procedure that we have to follow. Now say for example that how I apply this in practice to physics. Well, let us come to that. Say for example you have a velocity given in the form of like this. Say for example you have a velocity given as, say for example, t square minus 2t plus 1. Now, as we know that the velocity portion is nothing but ds by dt, so I can go on writing on ds by dt is equal to t square minus 2t plus 1. Well, if I want to find displacement from here, then I do operation what in calculus I call it integration. Well, what does integration mean actually is nothing but addition of very small quantities. Now let us see that what exactly an integration stands for. Well, in the case of an integration, if I have a formula for x to the power n, I should give it as x to the power n plus 1 divided by n plus 1. Well, now check me out that how I can get this value from a assigned value. Say for example, I am given to integrate x cubed. So how I operate this? I put it as 3 plus 1 and here as a power of 3 plus 1. So what I have is 1 by 4 x to the power 4. So you can see one thing for clear that the integration process is associated with increasing the power, while the differentiation process, say if I recollect x square again differentiating, then I had it 2x. So there is a decrease of power here. So that is eventually what we are doing, that here the power increases and here the power decreases. Now let us come to a practical process, an actual process of this integration and differentiation. Say for integration, particular value, differentiation, or you can consider it integration, whatever it may be. For a practical value of, say, I have it like this, there is a displacement which is given as s and it is given as t square plus 2t plus 1. And now you are asked to find the velocity. What is the velocity at t is equal to 2 seconds? So this is the question. Now as we know that if I differentiate s, we have already learned that what is v? V is nothing but ds by dt. So what I am doing fundamentally is that I am differentiating this whole thing which I call t square plus 2t plus 1. Now when I differentiate this, we have already learned that the differentiation of t square is nothing but 2t. And I hope you get this, that if I differentiate t, then what will happen? You tell me what will happen. The power is 1 here. So it is 1 minus 1, 0. And then a multiplication of 1 comes here. So eventually it is simply 2 because t to the power 0 is 1. So I have the answer of differentiation as 2t plus 1. Now what about this constant here? Well, you should know that when I differentiate a constant, the value is 0. So this differentiation occurs as 0. and this t is occurs as 1. So I have a value of t square plus 2. Now that differentiation is 2t plus 1. So 2t plus 1 differentiated value gives a time of 2 seconds plus 2, which makes me 6. And I put the unit of velocity, which is 6 meter per second. Now if I go on to another example, say for example, you are asked to find a particular value of s is given here. Say it is given that s is equal to t square minus 2t plus 4. It is something like this. Say it is 4t square, something like this. Then what happens? They ask me that at what value of t will v be 0? So in that case, what I do? I start with v. V, as you know, is ds by dt. So as I put ds by dt, I differentiate that one. So it becomes 8t. I hope you got 8t. Then it becomes minus 2. So now as it comes to 8t minus 2, your v is 0. So this should be equal to 0. So that comes to t 2 by 8. So that is 1 by 4 second. So 1 by 4 second is 0.25 second. So at time 2.5 second, the velocity of this particle will be 0, which have a displacement relation with time as this. Now I will give you one more so that we can understand that how integration takes place. Well, if I go to integration, say for example, I have an equation of velocity now. So I have velocity, which is 3t square plus 2t plus 1. And I'm asked to find that what is the distance traveled, what is the s when t is equal to 1 second. So now you're asked that what is the distance when t is equal to 1 second. So now what you do, you integrate. As we know that v is ds by dt, as I've already shown you earlier. It is 3t square plus 2t plus 1. So now I integrate all these things. I integrate 3t square plus 2t plus 1. So you see, when I integrate this, what I have is a result of 3 1/3 of t cube plus 2 half of t square, and 1, as you can understand, it will happen to become t. I'm sorry, it is t. So now if you substitute the values, what you have here is t cube plus t square plus t. So you have a value of t cube. So your distance now stands at t cube plus t square plus t. And then you substitute the value as 1. So it is 1 cube plus 1 square plus 1, which happens to be 1 meter. So now what I want to make one portion clear is, you see, if you integrate ds, it simply becomes s. If you integrate dv, it simply becomes v. If you integrate dt, it simply becomes t. So I hope that you have gotten a sense of how you do the operation actually in calculus as differentiation and integration is related. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.